This video covers question 3, part B of the 2022 AP Calculus AB free response section, calculator not allowed. So I'm going to break down this question into 4 different videos, and so whichever section you're looking to find out about, you can watch a video on that individual section, or you can watch all 4 of them. So this problem, the first thing I do on any AP Calc question that has a graph is I want to make sure I know what that is the graph of. And so what we're looking at right now is the graph of f prime. We're looking at the graph of the derivative. All right, check. Now let's go see what they're going to ask me to do on this problem. So they want us to find the x-coordinates of all points of inflection on this of the original graph, right? From 0 to 7, and then of course justify the answer. Not enough just to tell them the answer. Well, let's talk about what it means first to be an inflection point. So an inflection point, the definition of an inflection point is that a point that has to fit 2 requirements. The first requirement is that our second derivative has to equal 0 at that point, or the second derivative is undefined at that point. Then the second quality that we need is we need it to change concavity at that point. It's not enough to just have a second derivative that's equal to 0 or undefined. It also has to change concavity at that point. So it must meet both of these requirements. Just doing one of those things is not going to be enough to get us an inflection point. So you say, okay, well, I need to find second derivative data, but I'm looking at a graph of f prime of x. I'm looking at the graph of not the original function, but the graph of the derivative. Well, to find second derivative data off of the first derivative, I just need to go ahead and read the first derivative off of that graph. If I read the first derivative off of there, then I'm going to get out second derivative information, and that's what I need to determine an inflection point. So to read a first derivative off of a graph, I just use what I call my derivative triangle. So when we're reading derivatives, we're reading off the slope. So wherever your graph is headed up and increasing, that's a positive slope and therefore a positive derivative. Wherever your graph is headed down and decreasing, that's a negative slope and a negative derivative. And wherever your graph would be going horizontal for a moment, that's a 0 slope and a 0 derivative. And while we're reading it off right now as positives and negatives as slope, remember, you're reading the first derivative information, which even though it's talking slopes, is telling you second derivative data. So for this problem where these things are positive here, that's really telling us where it's concave up. And then when it's negative, that's really telling us where it's concave down. And then the horizontal, that's really telling us where we're running into this possible inflection point. So the first thing I'm going to do is I'm going to read the first derivative data off of this graph. So I come over here, starting on the left-hand side. My graph is headed down, so this would all be negative, 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 until I hit the bottom there at 2, which would give me a 0. So there's a possible inflection point. Then after that, this graph is going up, so positive, 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 positive. And then at 4, you get a sharp corner right there. So that's not a 0 slope, but where things are sharp, that's where our derivative is undefined. Remember, a derivative needs to be smooth and continuous. So at x equals 4, we have another possible inflection point, but we have it from the undefined version of this. Then we keep reading off our derivative data, so plus, 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 and then we hit another sharp corner up at the top there at x equals 6, so that's another undefined situation. And then after that, we go negative, negative, negative. What I like to do from there is kind of pull that off into doing a second derivative test, what I just call the number line game. So what you would do is you would mark your possible inflection points. So we said we had a possible inflection point here when we got that 0 at x equals 2. We had a possible inflection point at x equals 4 because it was a sharp corner, and then we have a possible inflection point at 6. So those are the three pieces that fit requirement 1 right now, that they have a second derivative equaling 0 or a second derivative that is undefined. Now we got to go through and see which of these also have a change of concavity happening. So coming back here, looking to the left of 2, I can see that all of that is negative. That's second derivative data. Remember, we're reading our derivative off of our first derivative. So what we're getting out is second derivative data. So that tells me that that would be negative and therefore concave down through that section. Then between 2 and 4, that is all positive. Positive tells us that it would be concave up. Then between 4 and 6, it is still positive, so it is still concave up through that section. And then after 6, we can see that it goes negative, and so this would be negative and concave down. So which one of these has a change in concavity? We can see that our inflection point at x equals 2, it changes concavity. It goes from concave down to concave up. At 4, it does not change concavity. It stays concave up to concave up, so that is actually not an inflection point. And then at x equals 6, it changes from concave up to concave down, so that is an inflection point. So in this situation, we would say x equals 2 and x equals 6 are inflection points. And then doing this second derivative number line right here is one way of justifying it. You're showing them your second derivative, reading your second derivative off the actual graph here is another way of justifying it. I would probably go with the number line along with this. And so from there, that would earn you your 2 points on section 3b. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.